Alright, so here we're going to look at the Chapter 4 review, so let's go ahead and jump on in. Find the vertex of the above equation, show all your work. At this point, with the test coming soon, you really need to make sure you know these formulas. So for the vertex, we're looking at negative b over 2a to tell us that x-coordinate. Looking here, here's our b, so we have a negative b over 2a. Our b is the 8, our a is the 2, so we have a negative 8 over 4. Telling us that our x is equal to a negative 2. That tells us our axis of symmetry down here. Also tells us the x-coordinate for our vertex. If you plug the 2 in back to the original equation, that will tell you what your y-coordinate is. Alright, so here we get 4. 4 times, negative 2 squared is 4, times 2 is 8. Minus 16 minus 5, that's negative 21. Put it together with the 8, and you get a negative 13 for your y. Alright, the y-intercept is always that c value on the end, so it's 0, comma, negative 5 in this case. Domain, all real numbers. Range starts off like this. And we have to think about what our parabola is doing. So we know we have our vertex at negative 2, negative 13. We have our y-intercept at 0, negative 5. Alright, here's our axis of symmetry. So we could reflect this point across. Now it's easy to see that our parabola opens up here. We also could have known that based upon our a value being positive. So we increase towards infinity as we go up. The lowest point is going to be that y out of our vertex, which in this case is a negative 13. And don't forget to put the line underneath the inequality. So this is saying that I'm always bigger than negative 13, and I'm headed towards infinity. All right, convert the above equation to vertex form. Now with this one, we're not going to have to do any calculations. A is shared between the two forms. Our a is 2, right there. And we know our vertex is negative 2, comma, negative 13. So into the vertex form we go. Y is equal to a, and then x minus h, so minus a negative 2 would turn positive. Plus 2 minus 13. Graph the following equation using 3 points. We did the vertex, the y-intercept, reflected it across the axis of symmetry, and there's that. Factor the following equations. If you can't factor, you need to see me for help. Hopefully you've done that up to this point. So on these, one thing to keep in mind is if there's ever a negative out in front, we need to factor that out right away. Switch all the signs. So now we are looking for, it's x and x because it's the only way to get x squared. This is the easy type. Numbers that multiply together. Alright, so now we're looking for numbers that multiply together to get a positive 18 that add up to a negative 9, which would be negative 6 and negative 3. Alright, this one here, as soon as you see a number out in front, you want to check for a GCF. Can I divide all these numbers by the same thing? I cannot. So technically on this one, it could start off as 2k and 2k, or this could be a 4k and a k. Alright, so we're looking for numbers that multiply together to give us 9, which are 1 and 9, 3 and 3. But in this case, they're not just going to add up to 12 anymore. It needs to be these numbers as they get multiplied by the 2's would then have to add up together to give us a 12. If you tried all the different combinations in this one, it would not work. This one ends up being a special case. And remember, the way you can check these is check the outside terms. 2k times 3 gives us 6k. The inside gives us another 6k, and that's what's given us our 12k there. But with this one being the same factor twice, we need to simplify it down to 2k plus 3 squared. Alright, this one here, we do have a GCF of a 2 n squared minus 49. Hopefully you recognize this is the other type of special case where we have n plus 7, n minus 7, because you could think of this as there being 0n, and so that's why we get a negative 7n, positive 7n to cancel out, giving us that 0n. Okay, so I do want to leave some of these factorings here for you so that you can get the factoring experience checking with the answer key on Plus Portals. Alright, so this one's just to solve the same equation from two different perspectives to help verify that this is the same answers. So factoring this one, I'm equal to 0 already, which is what we want. It's the easier type, so I have x and x. Numbers that multiply together to 21 that add to negative 10. Negative 7 and negative 3. So the zero product property then has us set these pieces up equal to 0 and then solve. So I'd add 7 to both sides to get that x is 7. I'd add 3 to both sides to get that x is 3. So now I'm going to do the exact same problem, except I'm going to complete the square, and I should expect the exact same answers. So I'm going to rewrite it for this one. Well, I'll just kind of show my work here. So I'm going to subtract 21 from both sides to clear that c value. So now I'm looking for what number goes here, but I'm trying to factor to the same thing twice. So I've got x and x, so if you divide that by 2, it's a negative 5 and a negative 5. Which then means negative 5 multiplied by negative 5 by negative 5 makes this bonus number here plus 25. And I need to add that onto both sides to keep my equation balanced. Negative 21 and 25 is 4. The whole purpose that we did that is so that we can have x minus 5 squared is equal to 4. Now we can square root both sides, giving us x minus 5 is equal to both a positive and a negative 2. And I need to incorporate both scenarios on that here. Adding 5 to both sides, you'll get that x is equal to 7. And you'll get that x is equal to 3, which are the exact same answers which we just got, because these are both methods of solving quadratics. All right, let's take a look at this third one here. I'll leave 2 up to you in the answer key. Completing the square, again, add that c term to the other side. We have x squared plus 2x is equal to a 7. So this would factor to x plus 1 and x plus 1, because dividing that 2 in those pieces. 1 times 1 makes our bonus number 1 here. So we now have x plus 1, twice is equal to 8. So x plus 1 squared is equal to 8. We're ready to square root both sides. X plus 1 is equal to plus or minus the square root of 8, which we can simplify down into 4 times 2. Square root that out. So we have x plus 1 is equal to 2. Let's get our plus or minus on there. Plus or minus 2 square root of 2. Subtract the 1 from both sides, and you've got your answer. All right. And sometimes on the ACT, well, I guess always on the ACT, they will put the constant first. So negative 1 plus or minus 2 square root of 2. Those are both the same thing, except putting the constant first. And this is how it's going to look after we do the quadratic formula. So let's do our quadratic formula. We have our negative b plus or minus rb squared. Mixing up my formulas. Square root of b squared minus 4ac all over 2a. All right, our b is a 2, our a is a 1, and our c is a negative 7. So we have negative 2 plus or minus. All this stuff underneath here is a 4 minus a 4 times a 1 times a negative 7. these negatives will cancel out. 4 times 7 is 28. So we get this here. And these cancel out. Notice that this negative turn this positive. So when we add these up, that's really a 32 underneath that square root, all over 2. All right, we can break up the square root of 32 into 16 times 2. Square root that guy, to put a 4 out front. So we have a negative 2 plus or minus 4 square root of 2, all over 2. Remember, we simplify these all at the same time, so I need to divide them all by 2. And when we do that, we are left with negative 1 plus or minus 2 square root of 2, which is the exact same answer that we had right here, which we expected, because that's just 2 methods of solving the exact same equation. All right, given the following graph, determine the quadratic in vertex form. Vertex form, y is equal to a x minus h squared plus k. It says that this is the vertex, so that's h, that's k. So here's how we do it. We've got y is equal to, we don't know a yet. Now, if this is minus h, my h is a negative 1, so it'll turn positive, plus 5. Now, I'm going to use this other coordinate point as my x and my y. They're both 3, so 3 for y, 3 for x. Now we're solving for a. Biggest mistake people make on this. 3 plus 1 is 4. 4 squared takes us to a 16. That 16 is multiplying by the a. So you have to have 16a. You cannot add that 5 onto it. People have been messing that up a lot. Now I subtract 5 from both sides to get negative 2 is equal to 16a. Divide both sides by the 16. And we get that our a is equal to a negative 2 over 16, which will simplify to a negative 1 over 8. Once we have that, we just need to plug that back in to this right here, making our final answer y is equal to negative 1 over 8. Let me clear this out. And then x plus 1 squared plus 5. And there you have it. That's also on old videos if you need to look back through. All right, this one here, we've seen it from the matrixy standpoint. You can see on the answer key how to do it with matrices. Another way would be push that stat button on your calculator, enter your x's and your L1s. All right, so in L1, you'd want your x's in there. In your L2, you want your y coordinates in there. Once you have that in your L1 and L2, and those are the only 3 points, push your stat again. Push to the right, go to calc, and then you want the quadratic regression. That'll tell you your A, B, and C values. When you do that, it'll tell you that A is negative 2, B is an 8, and C is a negative 8, making our equation y is equal to negative 2x squared plus 8x minus 8. If you want to see the matrix version, check out the answer key. If you know how to do that stat method, it's faster, and we'll be able to also look at that together in class on Thursday.